The topic that I wanted to discuss with you, that what is the relation between SOTIF and AI? Because we discuss SOTIF in a great deal in an autonomous driving setting, AV setting or ADAS setting. Welcome back to yet another episode of Matrix Tech Talk. Today we have a very special guest, a senior functional safety expert from TÜV Süd, Dr. Simon Resner. Simon, welcome to Matrix Tech Talk.
Hi, welcome.
Simon, why don't you tell our audience a little bit about yourself, your passion, your background?
Yeah, so I actually started engineering from the side. So I used to be a physicist, doing my PhD in physics, actually theoretical physics, and so I came to software development and these kind of things, and ended up in aerospace and started to learn about processes and safety-driven development, and kind of got this passion also. Then switched to automotive, and then after some time came to TÜV Süd as an expert for functional safety. So from my background as a physicist, I like looking at things from the theory, from the principles. And in functional safety, I think this is a very interesting and important point, that safety is always something that's overarching, that's for all the system, for all the product, it has to be safe. It's not one aspect that can be dealt with in the details. And I think this kind of helps me in this functional safety business. And also the emphasis on analysis. So coming from physics, you're kind of trained to think analytically, and you do a lot of analysis and a lot of documentation, and this kind of helps me getting along in functional safety.
Fascinating, Simon. So today we're going to focus on a very special topic in functional safety, safety of the intent and functionality, SOTIF. For our audience, can you first define in a layman's term, what is SOTIF and why is it different from traditional functional safety?
Yeah, so traditional functional safety always assumes that something goes wrong in the system, and that's why it's not safe. And SOTIF starts actually earlier, saying, okay, let's assume the system is as it is, and it is as it is designed. Is that in itself safe? So actually, SOTIF is the first step in safety, asking, is the function itself safe? And I think that's what they wanted to express with this safety of the intended function. The intended function is what I wanted to implement as a customer function. And SOTIF asks the question, is that function as it is defined safe for customer use? And only after that basically comes the question, what if it fails, if it doesn't work, how it's supposed to work? Yeah, I think that there are examples how to explain that. I mean, some of them are maybe little drastic, but let's think about weapons or knives or something. And the intended function is, of course, for a knife that it can cut something. And then you can ask the question, is the function of cutting something safe? And then you will find that actually it's not safe. I mean, you can cut yourself. And so to make it safe, you would have to define measures. And let's say that kids cannot access the knives. So that would be the SOTIF thing. And then the functional safety thing is, if I cut something, can it break? And because it breaks, I slip and then I cut myself. So actually the SOTIF thought is actually earlier than the functional safety thought, the idea.
I love it. I love the knife metaphor. So, I mean, the intention of building a knife is to chop vegetables, for example. But if you use it or if you misuse it otherwise, other than the intention of this function, that is not the intended function, and this is what you want to prevent. And this is what kind of SOTIF is about, right?
Right. As you see with the knife example, you already have different ways how to prevent this hazard of cutting yourself, or that somebody cuts someone. I mean, this is first access, for example. You could put it in a special drawer. You can train people that they know. I mean, you tell your kids, be careful with the knife, yeah, and these things. And then at the end, you can also try to design a knife that doesn't cut humans. I mean, this is for a knife, it seems strange, but if you come to automated driving and ADAS function, then I mean, it becomes maybe more clear that you can also try to design the system in a way that it cannot hurt or endanger people.
So let's bring it down, bring this example, extrapolate this example to automotive scenario. We've been talking a lot about ADAS or AD related functionalities. So how does this example translates to autonomous driving or ADAS or today's technology that we have in the vehicle?
Yeah, so in the past, functions were rather easy, rather simple. So driving was accelerating, braking, and so on. And then it's very easy to understand quickly what's the implication of this function. But as it comes to automated driving or also ADAS functions, it's not so easy to overlook all the implications that this function might have. And that's where the SOTIF idea comes in. The question, is that function as it's defined safe? That's why now with automated driving, the SOTIF idea comes up and is so important, because now it's not just one Excel spreadsheet or one table that you write down with cases and find out, okay, I can go through with my mind, I can go through the cases and decide whether it's safe or not safe. Now this list seems to be unending. I mean, if you think about traffic situations, you have so many different varieties and variations of traffic situations that it's very difficult to say in any case, the function behaves right. I mean, it already starts with behavior according to traffic rules. You say the vehicle goes through traffic and is supposed to behave according to the traffic rules. And what does it mean? And for human drivers, we always assume that each driver has some minimum common sense in a way. Decide case by case. I mean, what's right in one time can be wrong in the other time, and you assume that each driver has this kind of gut feeling. And now for an automation, it's very difficult question to answer. Does it have this gut feeling to do the right thing in the right place? Yeah, so that's, I think, why SOTIF comes along now with ADAS and AD functions.
Mm-hmm. We have a lot of ADAS functionality today. You know, we have lane keeping assistant, we have distance control, we have, I mean, we're almost toward level 1. With these technologies, where do you think, with an example for our audience, if you can explain, that SOTIF will make it more safe or secured for the users?
So the example could be this emergency brake assist. So you want to make it safe. So basically, this implementation of this emergency brake assist should harm nobody, right? So what it does is pretty clear. It's supposed to brake before you hit an obstacle, so that you yourself and the people in your car are safe, and you're supposed to protect other participants that are vulnerable, like bicyclists or pedestrians. You can now define the function and ask, when do I start to brake? I mean, when it is clear that I'm going to hit it, and then you define a certain point in time when you start to brake, and you define how strong you will brake. And then you can prevent basically this primary hazard of hitting someone. But in some situations, doing that itself might be not appropriate. So if you do a very strong braking and someone is behind you, then they might hit you as well. So this action that you defined for the automated brake assist, that for this primary idea of not hitting someone in front, is perfectly right, and hitting the brake is perfectly fine, but someone behind you might be in danger. And then you have this discussion of false positive and false negative braking. So you will never be able to design a function such that you don't have any false braking or false non-braking, because that would assume that you have perfect perception of the environment and perfect decision taking. So let's assume you don't have that. And then you have this issue that you have to deal with the fact that you can harm someone behind you, and in front of you, you have to equally level that out, your function. So you start designing or updating your intended function in a way that the overall risk is minimized. And of course, if you find out that this minimization is not enough and the total risk that you can get with this update or improvement of the function is not sufficient, then you would have to take some additional measures and make other things outside of your system, which is, of course, always very difficult. But in the end, that would mean that you have to take additional measures. In the end, I mean, SOTIF makes it safe because it asks the question at all. And if you have the facts on the table, I mean, how much is the risk? You can decide whether you want to accept it or if you cannot accept it. And I think that's the primary way how SOTIF makes it safe. It starts to ask the question in the first place, I mean, is it safe? And then comes out with a result. SOTIF is supposed to come out with a result. This is the risk. Do you want to take it? Yes or no? Do we still need optimization? Can we leave it that way? So I think that's the first entry point why SOTIF makes life or automated driving more safe, because it starts to address this question.
Fascinating. So now let's talk about the standardization part. So ISO PAS 21448 is available. Now, tell us a little bit about the standard. How does the standard cover this kind of situation, and what does the standard prescribe? How is the standard?
Mm-hmm. Yeah, so the standard actually started out, I think, in this very early stage. I mean, we see that in other technologies and other fields that first things are applied in the field for several years, and then people start writing a standard. And now for SOTIF, this is somewhat different. People realize we need a way to go ahead, to proceed, as the effort of making or to creating automated driving is so high. The different companies want to coordinate. And so this standard also came about as a kind of means to coordinate the way how you go forward. And that also made the standardization work for the people in the committees very difficult, to really write down the essence, because you write down the essence of something that you have not really experienced for 10 years. And so seeing that and also seeing the fact that many people say we still need openness for new ideas. So they hesitated to write down nitty-gritty details how you do it, because then you kind of close the door for new ideas. And that's why this 21448 standard is rather high level. It gives you the guidance which direction you have to go, but it doesn't go into detail how exactly you need to do it. This is, on the one hand, it is a strength because it leaves this space for new ideas. It doesn't tell you have to do it that way, but it leaves it up to you. If you have a great idea how to do it, you can still do it your way and have an advantage relative to your competitors. Because you're doing it maybe in a more clever way than they do it, right? The disadvantage is, of course, that you have to do that thinking. It just gives you the very rough direction you have to go. It says where you should end up, and that's in between, it's up to you. So the standard basically, if you compare it, for example, to the 26262 standard, there you have targets for, let's say, some hardware metrics. It says you should reach that. That is sufficient. And here you have to think yourself, I mean, what is it that is sufficient, that the risk in the end is acceptable? So the primary objective in 21448 is always the risk that you will have. So it asks you, make sure that the risk in the end is acceptable. And that's where it leaves you, basically.
Yeah, besides the standard, let's dive a little bit, take a little bit deep dive in SOTIF. Like, what are the key elements? How are the hazards defined? Like, we do a hazard and risk analysis when it comes to ISO 26262 functional safety. Is there any parallel to that that you do in SOTIF?
Yeah, so actually these principal ideas from safety engineering, of course, also went into 21448. So the idea is, first you start to analyze your system regarding hazards of the overall system. So this is very much alike this hazard and risk analysis of the 26262. So this first step is basically the same thing. It basically asks you what is the hazards. And if you look at the HARA in 26262, you find that root causes are actually not considered in the first place. It's only the effects, yeah. And this kind of, what's the effect, what's the hazard, that's the same step in SOTIF also. And then once you have that, you get some slight deviations. First of all, because SOTIF also covers misuses, so that's something that 26262 kind of excluded and said, okay, misuse, I mean, it talks about reasonable foreseeable misuse, but it's only basically a background situation. So in your situations, you can also have misuse situations. And in this situation, you have a malfunction and then something bad can happen. For SOTIF, it promotes basically this misuse because it can also be the cause of the hazard or the harm. The misuse can be the source of it also. So you have to extend your view a little bit towards these misuses for the SOTIF analysis. But otherwise, this first entry point is very much alike. And then as you go into details, as you start asking for root causes, why does that actually happen, then the deviations come in.
So the root cause is something that SOTIF goes in detail compared to ISO 26262.
Right, it's a different kind of root cause. In 26262, it's the malfunction, yeah. And in SOTIF, it can be either misuse or it can be triggering events, yeah. But probably the standardization committees will replace it by triggering conditions. So it's a condition of the environment, of the outside, of the overall situation that triggers the system to do something that is inappropriate. So you cannot say it failed. I mean, it did what it was programmed to do. I mean, it was designed.
But it was not intended to do.
Yeah, that's. I mean, we are entering now a very subtle discussion. What does this intended mean? I mean, people have been discussing a lot. I mean, it suggests that intended is something that somebody has in his or her mind and thinks about. But definition in 21448 is actually that it's the specification. The intention is the specification, which is, of course, a shortcut. I mean, because on the way from your mind to the specification, you have a lot of traps that you have to come over before you have to actually have it.
Right. You'd mentioned this external trigger. Now let's talk about it. Statistically, we have more casualties outside of the vehicle than the passenger inside the vehicle today. So it is important that we think about external triggers and pedestrians or bikers. So is there any casualty risk analysis or that sort of a risk analysis that is prescribed in SOTIF?
So for this risk analysis, it doesn't give you any categories, basically. It doesn't say that the driver is has to have a certain risk and the outside people have a certain risk, it keeps that on an equal level. So it just says the overall risk has to be acceptable. It doesn't do any weighting who is affected. Yeah, it's just if anyone is affected, it's an issue. I mean, there have been discussions about risk acceptance. For example, the Pegasus project has discussed that or recalled research that has been done for nuclear energy. And they found that people are more willing to accept risks of technology that has any benefit for them. So basically, you can assume that the driver has a higher risk acceptance than some outside pedestrian who has no benefit whatsoever of somebody else using that car, because for him or for her it's just in the way of a car. And so, yeah, this is something that's not described in the standard, but it's something that you might consider, that the risk acceptance in society differs not only from country to country, but also inside each country of what benefit do I have from automated driving. So if it's my business, this automated driving, I'm making my living with automated driving, then I'm willing to accept much higher risks than some pedestrian who doesn't even have a car. But the standard basically says it's risk in general. So basically any person at harm should not be harmed, and the risk of harming them should be acceptable.
Amazing. So let me switch gear to and enter the topic that I wanted to discuss with you. That what is the relation between SOTIF and AI? Because we discuss SOTIF in a great deal in an automotive autonomous driving setting, AV setting or ADAS setting.
Yeah. So basically, I think the appearance of SOTIF and AI kind of are correlated in the way that there are common settings that make both of them important and come about. And one thing is that this traffic situations, what's sometimes called the open world problematic, the fact that this world is so highly complex on our roads that we cannot fully describe it, triggers basically both of these developments. First of all, you need SOTIF to say, I mean, we need to discuss what these actions are that we do. Are they safe? Are they safe in all situations that can come along? And I think AI also came along with that question, saying, okay, I have a task to solve, which is foolishly complex, and it's really not possible to write everything down in a specification and a requirement form, what it should do in whatever case. So we said, okay, let's have the system learn itself what it should do. Yeah. So I think this complexity of the task is what made both things come along. I mean, AI to solve the problem at all, to make it work at all, and then SOTIF asking, I mean, now I have a system that's functioning maybe even in a easy to understand way, like this emergency brake assist. It's easy to understand what it does, but it operates in a highly complex and a highly versatile environment. So that, yeah, the question, is it safe anytime, is a difficult question to answer. And I think this is why these two topics come along at the same time.
In automotive industry, we've been used to requirement-based testing. Now, SOTIF requires scenario-based testing.
Let me ask you, with scenario-based testing, how do we quantify risks? Or is it a qualitative test? Tell me about what does SOTIF say about qualitative and quantitative testing or risk analysis?
Yeah, you mentioned requirement-based testing. I mean, has been this workhorse of safety for a long time, and people have been doing that, and that was based on it. And now that we discover that we cannot put everything that happens in the outside world into requirements, and that our description of the environment and all the situations is not complete, then you can also come to the question, I mean, what's the worth of requirement-based testing? I mean, you come to the end of this methodology due to effort and this high complexity. So idea was to introduce basically this a new way of testing. And in a way, I think this scenario-based testing is the trial or the idea to introduce some equivalence classes to put this highly complex outside environment into boxes and say, I mean, this is the same thing over and over again. So we classify things and put it into different boxes. And so we can pick one test from each box, and then we can see how do we have to vary the parameters in each box that we have coverage and can be pretty sure that everything's safe. So I think that's the idea of scenario-based testing. And I think for SOTIF it is so important, this scenario-based approach, or anyhow, you need, I mean, if it's scenario-based or if you choose some other approach, what you need is a means to start to address this complexity of the outside world. I mean, this is the problem, to address this complexity of the outside world, to put it into test cases that you need for verification and also for validation. And currently, I think the scenario-based approach is the best thing that we have on the market. I mean, this has been elaborated in many ways. So I think this is the current state of the art, how to address it. You classify the complex environment into different boxes, in quotation marks, having the different scenarios, like overtaking or taking right and left turns and so on. And then you discuss, I mean, within this group of right turns, what is the critical parameters that I have to vary? How is it the speed that I have to go through, or is it distances to my neighbor, or is it time to collision? And then you walk through and discuss which test cases you actually need to reduce test effort, and hoping that this systematics gives you at least the notion of coverage. I mean, this is the other functional safety workhorse in testing, coverage. I mean, you have some metrics and you say, let's reach a certain coverage. And that gives you a feeling, can I quit testing or do I have to continue? Now that you say this open world is so highly complex and has so many parameters, you suddenly end up with, you don't know what's 100%, right? I mean, and so it's difficult to address this coverage. And I think this is where the third keyword that you entered, I mean, this qualitative versus quantitative comes in. I mean, I can make it quantitative if I know this 100%. If I know what's everything, then I can say I covered with my testing, let's say 5% of all the real world things. And then I can really statistically boil it down using statistical mathematics into a residual risk. I can make an assumption how often does each situation take place. I mean, depending on the use case, I mean, maybe the urban scenarios are more important than, let's say, highway scenarios. This is all that comes into your calculation. And then in the end, you can come up with some residual risk, basically. However, if you now say, I don't know what's 100%, I don't know if I covered all the situations that are relevant, then it comes to a more qualitative thing. I mean, do I believe that what I did was reasonable? Because doing the number crunching is very difficult. You have so many parameters that come in, and if you say each number that you plug in has certain error bars, certain assumptions behind it, certain possibilities to have systematic issues in the background, then the question is, the final number that you work out, I mean, what does it mean? I mean, what's the error bar on this final number? And some people, I mean, currently nobody has done that in full detail, at least to my knowledge. And I think you have these two groups of people, one saying if you do that in full beauty and full detail, you end up with a number with error bars that are so large that it doesn't tell you anything anymore. So where's the point of doing it at all? And then you have the others that say you can still do it. It's an open discussion. I think so far nobody has shown that you can do all the number crunching for all the methods and then come up with a number, coverage or residual risk or whatever this number is that makes things comparable. So that some people say they doubt that you can possibly do it and say, okay, we need qualitative arguments
Right. So it'll have to be a mix of quantitative and qualitative. All right. So you talked about coverage in your answer. So before I go to coverage, I want to ask you one question. That did you imply to say that requirement-based testing will be replaced by scenario-based testing, or do you say that we'll still need requirement-based testing? Because the reason I'm asking, because when an OEM contracts a tier 1 or a tier 1 contracts a tier 2, the contract is based on requirement, right? You fulfill the requirements, the features, and you get paid. Now, if scenario-based testing comes up, how will that affect the supply chain, the DIA that we do between the OEMs and tier 1s and tier 2s? How will that affect? So what's your take on that?
Yeah, so I think requirement-based testing will still be important. First of all, we will need it for functional safety anyway, and also for this verification of SOTIF. So the verification task will, in very large amount, be covered by requirement-based testing. And the third point is what you mentioned. I mean, we're doing business with different companies, and you need something that you can count to say that.
And get paid.
Yeah, it's ready. You did your job, and you need something measurable. However, I think in the end it will not be sufficient to achieve safety in terms of SOTIF. Because if some OEM sets up a system, designs a system, and writes down the requirements that they can think of, what they possibly need, and put that in a contract and hand it over to the tier 1, and let's say the tier 1 comes along and does that again to the tier 2 and so on, and then it turns out that a sensor maker, let's say it's a camera maker, comes up with certain technological restrictions that will propagate up to the full vehicle level. So these things will have to be modified again. So maybe the assumption that a camera with a certain performance is available and is makeable, that the OEM came along with, is not true. Maybe this is not possible. And then basically all these requirements change. And of course you can now play the full basically contract thing and say we have lots of change requests and you change the requirements and so on. And you can go through all the loops. But I think, especially for SOTIF, in the early stages of developing a function, you will have very many of these iterations, figuring out what's actually needed on the OEM level, what is it, what they can sell as a function to a customer, what they need to find out what is the customer need. And then on the other end, you have really these technological companies that really try to make top-notch sensors and top-notch algorithms that come with certain technical restrictions of just what is currently state of the art and what's doable. And you have to get that together in a way. And this process of the supply chain is now, I think, not only, I mean, in the past, it was more like, I have a task and I hand it over to you because you can do it better and more efficient. And the task is well defined, and then you give me that part that I need. And now it's also more in the development already. You have this, I mean, many people say it's agile. I don't know if it has to be agile, but you need for SOTIF a very high information exchange on the different levels, from OEM, from vehicle level to system level, up down to the components. And I think on that level, you will deviate from the strict requirement-based thing. Of course, you can try to write down everything in the requirements, but I think at some point you will fail. So let me try to explain why I kind of have some doubt that requirement-based engineering in its pure form can cover it all. It is again connected with this open world and complex world. And let's say the car maker has this requirement, the car shall obey to the traffic rules. And this is a very abstract thing. What is the traffic rules? Of course, I can look it up, what that means, what is the traffic rules. But then next level, I start writing requirements more detailed. If somebody's to my right and there's no traffic sign saying otherwise, then I have to let them pass first, and so on. And through each step of writing requirements in more detail, I have to go back to this complex environment and get information on some details. For example, on high level, I say pedestrians should be recognized. So I need a pedestrian recognition. And then on a lower level, somebody will ask, what is it actually that I can discover that this is a pedestrian? I mean, does it all pedestrians wear shirts, or what is it? What's the feature that each pedestrian fulfills so that it's recognized as a pedestrian? And so I think this process of taking more information from the outside world, what is it actually like, will happen on each level of detail. And what sometimes in the functional safety community called design assumptions, you have to write down your design assumptions. That will be a rather big book now for each level, that you make some assumptions, and that's something you cannot cover everything in requirements. And then you can also come to the end to requirement-based testing. And also, I think that the contracts need to be more flexible for these things that, the camera maker has to make some assumptions that are not detailed the level above. So on the level above, maybe certain things are not defined and they are not appropriate for that level of detail. And then the level below, the camera maker has to say, this is how I address it. And so I think on each level you will have this assumption booklet. And
I love it.
Yeah.
One or two last questions. So to sum it up, requirement-based engineering will be there, and you'll have scenario-based testing. First of all, I've seen some of my clients are struggling to get a traceability or linkability between the scenario-based testing and requirements. That's the first question. How do you think they should deal with it? Do you have any suggestion? The second question is there any way take advantage of scenario-based testing to reduce cost on the requirement-based testing? Because I can totally see that there will be an overlap. These are not disjoint sets. There will be overlaps. So what do you think about these?
I think that the requirement-based testing is approach for vehicle level. So basically on vehicle level, I think it's still possible to connect the requirements to the scenarios. You can write a requirement and say, on a vehicle level, I have a certain requirement, the vehicle shall recognize pedestrians, and then I can pull out all the scenarios that have pedestrians. And then I can, of course, link those scenarios as tests to that requirement. And I think on that vehicle level, scenario-based testing and requirement-based testing just goes hand in hand, goes along. And I think the difficulty comes on if you go to lower levels, so you go to system level or component level, because then you also have to answer the question. Let's say you look at a certain component, and you have to ask the question: what role does my component play in that certain scenario? And I think that's becoming a very difficult question. And there, I think it becomes difficult using scenario-based testing, let's say on a component level. Of course, I can use a camera or radar or whatever it is and put it into certain scenarios, but it becomes, as you say, difficult to link my certain requirement. For example, I have a range requirement for my radar. How do I link it to the scenarios, and why do I need it? This becomes more and more difficult. And I think that's where the scenario-based approach kind of comes to its end. I think the scenario-based approach is very good for validation. So on the top level, to see what the end product, the final product, has achieved, their scenario-based approach is very good. But I think on the lower levels, you have to walk all this path from, what answer this question: what does my component or my part or my system, what role does it play in this overall scenario? And I think that's very difficult to answer. And I think that's where it comes to its limits.
Mm. So what you're saying is we should focus on scenario-based testing at the vehicle level. Can we also do it at the system Definitely at the component level, as you gave the example, it's very difficult. But would you also recommend at the system level, the scenario-based testing?
Yeah, I mean, if you do it on system level or component level, then you basically have to make a realistic situation. Then you come to this hill and sill situation that you have parts of the reality that you have to mock up for your system. Then I think you can still apply it. Then you can throw scenario in your tool chain. In the tool chain, basically, yeah, the model in the loop, the model in the hill simulation replaces the real world and stimulates the system and so on. And then you can again play this scenario thing, and then of course your hill system or sill system answers this question: what's the role of my component in the overall scenario? But this question remains very difficult, because then the model maker, the guy that sets up the hill and all the software for the hill, that guy has to actually answer this question or make all this thinking. What is actually the role, and which scenarios do I play in? Of course, I can, if I have it on hill and still, I can be more brute force. I have much more capacity to do scenarios. I mean, this is the whole idea of doing simulation, saying on a computer, I can run thousands of scenarios within a second or whatever. And in the real world, I need days and months maybe to run all those. And that's, of course, then how you can cover up for your unknowing. Yeah, you can just try out. I mean, it's cheap. I don't know exactly what's the meaning of my camera in the real world. There's also many research work being done on how to select cleverly which scenarios do I put in this simulator and which ones are maybe covered by others.
Simon, it was fascinating talking to you. Thank you so much for being with us. It was a pleasure.
Yeah, thank you too.
Thank you so much for watching, listening, or being part of our podcast. We will be making a series of podcasts on the topic of SOTIF. So stay with us. If you would like to know a particular topic around SOTIF, please write in the comment below. We would love to address this issue for you. So please stay with us. If you have liked this episode, hit the like button, write comments, and stay with us. Thank you so much.